So do you want to try the pronunciation on the record or
Dijkstra.
close?
Dijkstra as the algorithm.
Dijkstra. Dijkstra. Bas Dijkstra. Is that right?
That's perfect.
Okay, Dijkstra. Thank you for training us.
There you go. Awesome. And again, thank you so much for. I know you were active with Innovate QA, but 3 events a month. So wow, that is ambitious. Awesome. Yeah, and before I forget, all the best for the conference. It looks really good, the
Yeah.
program. So I hope it's going to be amazing. Um,
Hopefully next year you can come in person.
I I will. Let's see what happens. Yeah, this year obviously it didn't work out because of scheduling and all that stuff. But who knows? Who knows? As soon as you have the date, let me know.
Sounds great.
Awesome. Let me start by could you please enable screen sharing for me, Tatjana?
Yep, you should be able to do that now.
Yay! Works. Awesome. Could you please confirm that you can see the world's ugliest slide deck?
Yes, we can see.
Awesome. I'm not going to talk too much about myself because I don't think I can top Tatjana's introduction. But hello, I'm Bas. I'm joining you for the Netherlands today. Um, and I want to talk about testing the tests. It's going to be a presentation in 2 parts. So first, I'll talk about why I think it's important to test tests and how tests can deceive you. And then we'll move on to mutation testing. I'll tell you a little bit about what mutation testing is, how it works, and I want to show you a little bit of mutation testing in action. I'm not going to actually run the mutation tests because it takes a little bit too long. I'll explain about it, how it works. Uh, you'll see the results and you'll see the code, you'll see the improvements. I'm not going to actually run the tests because that's just 5 minutes of watching a progress bar. Um, I can think of better things to do. Um, so we keep saying this all the time. Test automation is software development, and I absolutely subscribe to this statement. Um, it's typically so, as the Chan already said, I do quite a bit of training. This is typically one of the first things that I focus on when I teach people test automation is good software development practices, how to write good code, how to write readable, maintainable test code, how to bring that in a version control, how to make that part of a build pipeline, all those things that really make our tests run. Um, so I say again, and I see this statement thrown out a lot, and a lot of people are really only paying lip service to it. But it is true. So we need, and part of, so we test our software. So we write tests for our software. That's what we do. Um, we do exploratory testing, we do automation for our software. But what I don't see happening a lot is people actually putting their tests to the test, and that's what I wanted to talk about today. And of course, we use tools to support testing. That's literally my definition of test automation. I use tools to support testing. I'm not looking to replace testing. I'm not looking to replace testers. I am looking to use tools to support my testing activities, to perform specific tasks in what I do as a tester in a more efficient way. Um, so yeah. So we write, part of that is again, is writing automated tests. And we spend a lot of time writing tests. We spend a lot of time running these tests. We spend a lot of time maintaining these tests. And the more we automate the process of building, testing, deploying, delivering our software, the more we rely on automation to do parts of the testing for us. The more we rely on the results of these automated tests as a to give us the go or no go to deploy, for example, to start building our project or to start deploying our software into an environment, which could just be your production environment. So we rely on these tests to help us get good insight into what is the current state of our product and are there any potential problems that our tests pick up. So we put a lot of trust in these tests. And again, the more we move to continuous deployment, the more automated that process is, and the higher the trust we place in our tests. What I unfortunately don't see a lot of teams do, or at least not do enough, is actually test our tests and guard the guards, so to say. This is my very lame attempt at looking wise, and I don't speak a word of Latin, but this is just a very a very what's the English word I'm looking for? Um, use, Useful. It's applicable to this situation. So I think we still need to start spending a little bit more time, not just looking into the quantity. So we all talk about the quantity of the testing that we do and the quantity of our automation. I would love to see a little bit more talk about the quality of it and people spending a little bit more time testing their tests and making sure that their tests actually do what they say or they'll do what they're supposed to do. Because your tests, unfortunately, can deceive you. Yeah, your automated tests, just the fact that that your test code compiles and that you see a green check mark when you execute your test, it means something. But it doesn't mean that all your tests are actually providing reliable information, providing trustworthy information, and even providing the information that you're looking for in the first place. And there's two different ways in which your automation can deceive you. You've probably heard of these before, false positives and false negatives. False positives are tests that fail when there's nothing wrong with the application of the code or the system that you're testing. So they signal a project failure, but your code works as expected. These should be dealt with as soon as possible because that they signal a failure, so they stop your pipeline. They stop your they stop the process of delivering your software or a change from a developer's computer all the way to production, maybe. And by dealing with these problems, I don't mean just ignore the tests and move on. Properly deal with this. See what the root cause of this false positive is. See what the root cause of the failure is. Is it a test data issue? Is it the test environment issue? Is it a timing or a synchronization issue? Anyway, deal with it. Make sure that the test passes again. And this is sometimes or often actually referred to as flaky tests. Those are the most annoying ones. Those tests that fail and that sometimes fail, and you don't really know why they fail and when they don't. And obviously, when you start debugging them, they never fail. But then you run them again, and you run them overnight maybe, and then they start failing. And so this is hard work. This is proper engineering work sometimes, but it's something that is very important to do because otherwise, all you get from your test suite is a lot of noise. And not a lot of signal, not a lot of useful information. And this is where people start to walk away from their tests and say, well, it's only noise that's provided. Let's just ignore them. And that's basically the beginning of the end for your test automation efforts. One thing that helps is making your tests as small as they should be, but not smaller. What I mean by that is try breaking down your big tests into smaller ones, because the smaller they are, the fewer moving parts they have, and the fewer parts that can cause flake, that can cause them to fail when they shouldn't. I wrote something about this a while ago. I'll share the links and the entire slide deck actually with Tatjana after the, so you can publish them somewhere if you want to. If you Google breaking down your end-to-end test, you should probably find it somewhere on Google too. The other problem, the other way in which your tests can deceive you is false negatives. False positives are annoying, but at least they make themselves known. A false negative is a test that signals that everything is okay, but it fails to detect unwanted changes in the behavior of your code. So that's a test that always says everything is okay, everything is okay, everything is okay, yet it should have detected a change, but it doesn't. Again, false positives, they are annoying because they generate a lot of noise. False negatives are silent killers. They say everything's okay, and they let a bug slip by unnoticed all the way into production, and then people start to get called out of their bed at 3 a.m. on a Sunday morning saying, why is this broken? This is what we don't want. So we want to avoid these, both the false positives and the false negatives, as much as possible, which means we'd probably be wise to spend a little bit more time talking about investigating, testing our tests, and looking at it, are our tests actually doing what they're supposed to do? I see a lot of teams talking about the quality of their tests in terms of coverage, code coverage, and that can be line coverage, branch coverage, statement coverage, method coverage, class coverage, requirement coverage, whatever kind of coverage. Unfortunately, it's not enough. That is not enough. Code coverage, again, in any of the forms that I just mentioned, tells me a lot about the amount of testing that you do. It tells me about how many tests you run, how many lines of code were executed during that test. It doesn't tell me a lot of things about how thorough my testing was. It doesn't tell me anything about the value and the reliability of the information that is produced by my tests. So, code coverage, statement coverage, requirements coverage, whatever, alone is not enough. To give you a quick example of why it's not enough, let me tell you again a highly simplified example. I've got a class here that represents a bank account. It has a type, it has a balance. I can create a new account, and I can call a method. One of the many methods for this class is an add interest method. It has some business logic, you say, because I can only add interest to a savings account. And I've got a test for that, which creates a new account, deposits some money into the account, adds a 5% interest. I don't know which bank it is, but 5% interest sounds good. And then it checks the resulting balance. Awesome. Test passes. Everybody's happy. 100% code coverage. The problem is, let's assume your developer comes in Monday morning after a hard weekend, not a lot of sleep, and they say, well, time to start refactoring this code because it can and it should be better. No problem. We have the safety net of our tests, so we can refactor safely. And they make a mistake because it's Monday morning and they didn't have a lot of sleep, unfortunately. So they refactor this code and they accidentally rewrite this statement to always return true. again, we are humans. We make mistakes. Absolutely fine. It can happen. But if we only rely on code coverage as a means of determining the quality of the testing that we do, we've got a problem here. Because this test that we wrote is still going to pass. And we still have 100% code coverage. And it didn't detect this unwanted change in the behavior of our code. This one I stole from, I think, Martin Fowler, who said, well, test coverage, it's a great way to find untested code. But as a quality target in and of itself, it is pretty much useless. And I hope that this little example gave you some insight into what happens if you only rely on code coverage as a means of determining the quality of the testing that you do. Again, it's a great metric for quantity, for quality, not so much. This is also something that I've definitely had to learn myself too, and that I'm teaching to others as well. I want to know that my test can fail, and I want to know that my test fails for the right reasons. If my test passes, if I write test code and my code compiles, so I do a lot of work in C# and Java, so I need to compile my code first. So if my code compiles and my test runs and it produces a green check mark, I start doubting myself. This can't be right. I don't trust myself. I have a natural distrust of the code that I write myself. And I try to teach that to others too. Sure, if you write tests and especially if you're relatively new to it, you should be absolutely proud that you write code that compiles and runs and produces a green check mark. That's the start. Please don't just commit, push, and run away for the weekend. Make sure that that test can actually fail when it should. One very simple way to do that is to just flip an assertion and see if it fails and if it fails for the right reason. A better way, even, would be to make a small change in the application code and see if the test actually detects it. And that's the concept of mutation testing. We mutate our application code. We create an in-memory mutant version of our application code with a small change. Then we run our tests to see if at least one of our tests identifies that change, causing the test to fail. This is the one time where a failing test is actually a good thing for developers and testers and everybody, because it means that our test successfully detects the change that our mutation testing tool created in our application code. And I want to demo that to you, show you what that looks like, show you what the output of a mutation testing tool looks like. I chose to do that in C#. Why? Because of the next slide. First, I want to very briefly introduce you the mutation testing tool that I'm using. So again, a mutation testing tool creates mutants, injects small changes in your application, not in your actual application code, but in an in-memory copy of it. So it doesn't actually change your code. So don't worry about that. It does everything it does in memory. Striker.net is one of the best and definitely the most user-friendly mutation testing tool for the .NET ecosystem. It's open source, easy to configure, and it produces pretty awesome reports and results. Of course, I don't just need a mutation testing tool. I also need code to test and tests to test, actually. And that's where RestAssured comes in. So you might be familiar with the RestAssured library for Java, which I've been using for a very long time, and which I absolutely love because it allows me to write tests for my HTTP-based APIs in Java using a very clear and readable and easy to use syntax. And over the last couple of years, I started doing a lot more work in C# compared to Java, and I was looking for something equivalent to RestAssured for C#, and I couldn't find it. So I thought, well, maybe I can build it myself. And that's where RestAssured.net came in. It's an HTTP API testing DSL for C#. It's an attempt to make writing tests for your HTTP APIs in C# easy and fun. Again, open source too. It is a C# port of RestAssured in Java. So all of the syntax you'll find in RestAssured in Java, you'll find in RestAssured in C# too, or at least a very large part of it. Under the hood, completely different because it's C# and not Java, but the external facing DSL, so the public API of the library itself, is very, very similar. And just to show you what that looks like, here's a test that performs an HTTP GET to a specific endpoint, retrieves location data for US zip code 90210, and it checks that the status code is equal to 200 and that the state associated with the first place in the result list is equal to California, because we all know 90210, Beverly Hills, California, Los Angeles. And so this is what I loved in RestAssured in Java, and I wanted to recreate that. I wanted to find that, a library that did something similar in C#, couldn't find it, so I decided to build it myself. One of the things I use to safely develop and improve and bug fix on RestAssured is a lot of tests. And so I rely on all of these tests in all of these classes to tell me when I did some refactoring, when I fixed a bug, when I added a new feature, did I not accidentally break something? Did I not accidentally fix one problem and introduce two new ones? So I rely on these automated tests because I run them locally and they run in a build pipeline here in GitHub Actions too. And I don't publish anything before all of these tests pass. So I put a lot of trust in these tests. And I want to know, well, are these tests really as good as they are supposed to be, as I assume they are? That's where mutation testing comes in. Again, I don't just rely on code coverage. I like to rely on mutation testing, actually, at testing my tests, seeing are my tests really detecting changes that my mutation testing tool injects in my application code. So I added that as a tool, and the only thing I need to do is tell it to run. And again, I promise you, I'm not going to have you wait 5 minutes because every build takes 5 minutes because it creates a lot of mutants. So it's going to analyze the test project. It's going to create, I think for this code base, around 500 mutants. It makes 500 changes, which means it's going to run my entire test suite 500 times. Mutation testing is a very powerful technique. It's also computationally pretty expensive. We'll talk about that in a moment. I just want to show you, let's show you that it's actually going to create those 500 plus mutants. And then I'm going to leave this and show you some actual results and how that helped me improve my tests. So it's 221 tests. Let's just leave this for now. It's all in the reporting too. Once it's done, again, normally it takes about 5 minutes. It creates out of the box. I didn't have to do anything. It creates a pretty good looking report. Let me zoom in a little bit so it's easier to read for all of you. It's 416 plus 122 plus 164, almost 700 mutants. 416 of those were killed, which means at least at least one of my tests failed due to this change that Stryker made in my source code. 122 survived, and 164 changes weren't even covered by tests in the first place. So my mutation testing tool does code coverage too, but it does a lot more than that. Let's look at a quick change. So I'm going to this one. Let's ignore those. Not that one. Not this one. Oh, it's actually a no coverage one. I think. Where are we again? So it's in the I'm pretty sure it's in the verifiable response. So I completely forgot which one so deserialization of a response. It's not in this. My apologies. .html, go back. Response, deserialization. This is what I'm looking for. My apologies. So one of the capabilities of this library is it's able to deserialize JSON or XML responses into C# objects. Meaning that it can create a strongly typed object which is easier to process and to handle than just a JSON or XML string. One of the things I noticed here in my mutation testing results is that this statement I didn't have any tests that threw this exception, meaning I have no tests that try to deserialize a response, but the response body is empty or non-existent. And so that's how you should read this line. I'm trying to deserialize an empty response body, basically, which is something that happens pretty often, because if you try to deserialize, this is actually pretty often used, well-used functionality. But I didn't cover it in any tests, which I think is pretty darn important. So I decided to add a test that calls a mock API that returns an empty response body. I try to deserialize it to a specific type, to a specific C# type, and I check that it throws the deserialization exception that you see referenced here. And then I ran my mutation testing tool again to see if there's any improvement in my. And as you can see, it's now green instead of orange, so that's good. And if I go to the same piece of code, where are we? That's this piece of code. I can see that it is now properly covered. So I don't see any notifications anymore that this code is not covered. So I have coverage, which again is a good start, but it doesn't tell me anything about the quality of my testing. The more important thing is that it also survived, or no, not survived, but it it created passing mutation tests. So Striker switched this or to an and, which was picked up by my test. It negated this entire statement, which was picked up by my test. It changed this equals to a not equals, which was picked up by my test. And it also replaced this empty string with a default string. And that also was picked up by the test I wrote, which means that I not only have a test that covers this piece of logic, I also know that if I change something here, if I accidentally make a mistake here, if I change this logic, chances are pretty good that it will make at least one of my tests fail because my mutation testing tool says so, which gives me a lot of, first of all, more coverage, which is nice, but also the confidence that the test that I write, that I wrote and that I run as part of every build will pick up the change. I don't get that confidence just from code coverage, as we saw in the example. And so code without, so I can cover code without coverage and killing two birds with one stone, because again, I don't just know, oh, that code is now covered with a test, but it's also covered with a test that actually will fail when I make certain types of mistakes when I refactor, update the code. Another example in this one, this is in the request, in the HTTP request processor. There is a bit of logic here. So one of the things you'll often see with API test is, or a useful capability is the ability to pass in cookies in the request, to include cookies with your request, for example, for authentication. The problem is, if I add a cookie to a cookie collection, I don't, and make the domain of that cookie, which is one of the properties of that cookie, it cannot be empty. But if I create a new object of type cookie, I can just set a name and a value and not set that. So the domain of a cookie limits the applicability of the cookie to requests to a specific domain. But I cannot leave that empty. So I had a piece of logic here that says, well, if the domain associated with the cookie is empty, set it to the host name of the request, which is a common and a very sensible default value. The problem here is this mutation that Stryker suggested and actually performed this change. So it changed the is null or empty to not is equal to null. That survived all of my tests, meaning I don't test this logic well enough. So I could just write another acceptance test, because all of my tests, pretty much all of my tests are acceptance tests, meaning they actually invoke, they build a request, invoke an HTTP endpoint, and inspect the response. The problem here is this is very specific logic. This is just, this has nothing to do really with sending a request and inspecting a response. It's just logic that I perform before I even send the request, which means I should probably isolate, make a more isolated test, make a unit test in play instead of a functional integration acceptance test, whatever you want to call it. I want to test this piece of logic in isolation. The problem is I cannot do that the way I wrote my code right now. So this signal, this piece of information from my mutation testing tool didn't just tell me, ooh, you don't do enough testing here. And so I did some testing. So because 4 tests actually covered this statement, but the mutation survived anyway. So I didn't test this thoroughly enough. But I don't want to write more acceptance tests just to cover this little piece, add this little piece of logic. I actually want to do this in a unit test. So that's what made me decide to create a separate class that contains this piece of logic and write some unit tests for it that do not, so I don't need a more expensive acceptance test that actually performs an HTTP call, creates an HTTP client, all those things. This is even more efficient. So the information given to me by my mutation testing tool didn't just invite me basically to create more tests, but also to improve the testability of my code by isolating this piece of logic into a class of its own and allowing me to test that in isolation too. And so that's another great benefit, I think, of what mutation testing does. It tells you, it gives you insight into not just how much you're testing, but also, well, maybe you can improve your code here to test this piece of logic better, more thoroughly in isolation. The final example that I want to give you is to not blindly act on all the signals, all the information that you get from a mutation testing tool. Generally speaking, especially if you have a large code base with lots of tests, first of all, mutation testing is a pretty time-intensive process. But second of all, it will generate a lot of information, a lot of signals. It's easy or it's tempting to say, well, I want my mutation testing score to go to 100 and to make all of the tests and kill all of the mutants. I don't think that's necessarily all of the time. So here's an example of one that I am happy to ignore, at least for now. One of the concepts that I'm using here is I'm keeping just to make my code a little bit easier to read and less error prone. I have an enumeration which says, well, which content types do I support? So right now I can work with JSON payloads, request and response, with XML, and with HTML. Striker here says, well, what happens if I negate this? So if it's not JSON, it's covered, but it doesn't make any of the tests fail. I'm happy with that because if it's not this, because I'm using an enumeration here, so this argument can really only have the value JSON, XML, or HTML. I know so if this fails, I know it's going to fall down into any of the other 2 else if statements. So I'm not going to spend a lot of time, at least not right now, to get rid of this specific signal. And this is just one of the examples of, so just like you don't need to blindly trust your tests, you shouldn't blindly trust the results or act upon the results of your mutation testing runs. There's always a human in the loop. There should be a human in the loop. Otherwise, I could have just fed this to an LLM and say, go fix all the things. I'd rather not do that. I'm more than happy for an LLM to help me suggest improvements or for tools in general to help me suggest improvements. But ultimately, I would like to have control over what I do and what I don't do here. And this is a prime example of that. I'm fine with ignoring this specific signal from a mutation testing tool for now, because I'm sure that the way I wrote my code, I know I wrote my code, it's not going to cause me any problems, in at least not in the short run. Um, that's just
But
a couple of examples.
Buzz,
Yes,
I'm
please.
gonna
Yeah.
do a time check really quick. We're at 47 minutes, so we're at the time
I'll
where if there are
I've got
questions,
five more minutes. Is that okay?
yeah, let's check. Do people have questions
Oh,
online,
sure.
or should
Yes.
we go for 5 more minutes and then do questions at the end? Oh, it's quiet. I had questions, but I'll save it for later. Oh, here we have a Lana question. Some teams implement a quarantine or purgatory phase for new tests to help prevent flaky tests from contamination they build. Mutation testing looks like a great practical way to put a new test purgatory in place. Have you done any mutation testing in this context?
Um, Definitely. So the first example is that I gave is a good one, because using mutation testing on again, to remind you, there was a piece of code that wasn't covered yet, and I wrote some error handling, and I wrote a test to cover that error handling logic. Um, Sure. And I like Lana how he said, well, that test, that new test that I write, it needs to earn its place into my test suite, into my build pipeline. Um, and using mutation testing, after I added the new test, again, didn't only give me the insight that now that piece of logic is covered, but also because my mutation testing tool created a number of mutations around that logic in my code, and that made that test, or at least one of the tests, fail. I have confidence in that test actually does what it's supposed to do. So yeah, I think we saw that, kind of saw that in action uh, right here. And because I now know that my tests can actually fail when something changes when something unexpected happens, when something changes in the behavior of my code. So absolutely.
Yes, thank you for answering that, because the typical rule of thumb with like the purgatory or quarantine phase is to run it at least 100 times. Any new test, any little new test. And like you said, I really like your concept of never trusting a test that you haven't seen fail. So that's kind of where that concept I see
Yeah.
a practical application for. And I just want to emphasize like personal gratitude for presenting this material. And Tiana, do we have a time to wrap up the last 5 minutes of Bas's presentation?
Yeah, yeah, we have 5 minutes literally. So if you have a question, just put it in
Okay,
put it
because I
in
think
Yes.
chat.
he said there's.
I'll keep it to under 5. No problem.
All right, because I think you said also there is a piece of code coming up that's addressing this particular question as well in part.
No,
Possibly.
it's something that we saw already earlier on.
Oh, my bad. Okay.
No
All right,
worries.
back to you. Thank you, Bas.
No, no problem at all. Thank you. So to wrap this up, am I there yet? No, well, definitely not. Just to give you an insight, I improved my mutation score with the work that I did from 59 to 61%, which means that there's still 39% of of the mutants that's either causing a timeout or not being killed, or there's just no coverage coverage for the changes. So there's definitely a lot of work still to be done here. Was this a useful exercise? Absolutely. Again, I now have much more confidence in at least some of the tests that I do write, and I actually improve the testing around some of the pretty critical exception handling of the code that I write for RestAssured. So a useful exercise, yes, absolutely. And I'm going to continue using this. There's still a lot of work to be done, still a lot of uh, especially around the logging and around certain types of exception handling. There's a lot of tests that I still need to write. And mutation testing is going to help me make sure that I don't just write the tests to cover that logic, but also write tests that I can actually rely on. So that's what the biggest win for me is here. If you want to get started with this too, again, Striker is, I think it's a great tool, but it's very specific to C Sharp. Pretty much every programming language out there has at least one popular mutation testing tool. So Java has PyTest, not to be confused with the PyTest for Python. Um, Python has MudMud. C or JavaScript has a Striker implementation too. So there's lots of different options there. What I would recommend, what I did is just run all of my tests on all of my code. Um, my test suite is fairly small. So that's doable. A typical mutation testing run for me takes about 5, 6 minutes, which is okay. But if you have a large code base, it's going to take a lot of time. So it's probably a good idea to start testing, mutation testing on a small part of your code and a small part of your tests. And I would recommend a start on the code that implements business logic, business rules, and or exception handling, because that's where it really shines at those uh, potentially pretty complex if then else statements, and where you actually implement the logic that you really want your tests to really test very thoroughly. That's the part where I would recommend using mutation testing to make sure that those tests that you write and run and rely on actually are trustworthy and can be relied on. I wouldn't focus on the absolute numbers and the percentages too much, just like with code coverage, but definitely I do track the improvement over time. So I'm very happy that I upgraded from 59 to 61%. I know there's lots of stuff to go, but it's progress, and that's what matters here. One step at a time. Um, and please don't run mutation tests for all of your for every build, because again, it's a very time-consuming process to run your mutation tests. It's also a very time-consuming process to go through all the signals and all the information that's produced by your mutation testing tool. And a final thing to remember, and I sort of kind of gave you that message already, but I wanted to remind you of that, is again, code coverage tells you something about the amount of testing that you do. Mutation testing is a great way to give you more information about the thoroughness of the testing. But in the end, of course, we need humans, we need ourselves to talk about and decide on what's the value of the testing that we're actually doing. Awesome. That's it. Was that under 5 minutes?
Yes, you fit right in. Good job.
Excellent. Thanks so much.
Well, I do want to say, like, this is amazing, right? It definitely, we never know the real test coverage by just looking at the code coverage numbers. So this helps a lot with figuring out, okay, do we actually cover the code in a proper way or not, right? So that's amazing. Thank you a lot for coming up with this. I think this is a huge help to us as testers.
It is one of those techniques that is super powerful and that I would love to see more people use. I've been sort of kind of interested in this for a long time now. I must admit, I'm not always walking the talk.